welcome back to my YouTube channel. I am Sushant S from the Department of Information Science and Engineering, and my USN is 1VE23IS04, right? And my subject is today data structure and applications, and the topic is optimal binary search tree. Today my topic is optimal binary search tree. So we need discuss introduction to optimal binary search tree. An optimal binary search tree is a data structure used to minimize search time. It organizes key in a way that the most frequently accessed keys have shorter paths from the root. This structure is particularly useful in scenarios where certain keys are accessed more often than others. Basics of binary search tree. A binary search tree is a tree data structure where each node has at most two children. The left child contains values less than the parent node, while the right child contains values greater. This property allows for efficient searching, insertion and deletion operations. Next, we discuss properties of binary search trees. Binary search trees offer an average case time complexity of search operations. However, in the worst case, such as when the tree is unbalanced, the time complexity can degrade to binary search trees. This efficiency motivates the need for optimizing the structure of the binary search tree. Next, importance of optimality. The goal of constructing an optimal binary search tree is to minimize the average search time. An optimal binary search tree takes into account the frequency of access for each key. This results in a more efficient data structure than a standard binary search tree, especially in skewed distributions of key access. Next, cost of a binary search tree. The cost of a binary search tree can be defined as the sum of depths of all nodes multiplied by their access frequencies. An optimal binary search tree minimizes this total cost, leading to faster average search times. The cost is influenced by the arrangement of nodes and their corresponding access probabilities. Next, we are going to discuss the dynamic programming approach. The construction of an optimal binary search tree often employs dynamic programming techniques. This approach systematically evaluates all possible tree configurations to find the one with the lowest expected cost. It includes determining subtree and their costs, recursively building up optimal binary search tree. To build on optimal binary search tree, we use dynamic programming techniques. The process involves calculating the cost of searches for different configurations and selecting the arrangement that yields the lowest cost. This method ensures that frequently accessed keys are positioned closer to the root. Next, we discuss the cost calculation in binary search trees. The cost of a binary search tree is determined by the depth of nodes and their access frequencies. The formula involves summing the products of each node's frequency and its depth. Understanding the cost structure is crucial for designing an optimal binary search tree that minimizes overall search time. Next, we discuss the advantages of optimal binary search tree. Implementing optimal binary search trees can lead to significant Performance improvements, particularly in applications, advantages include reduced search times, efficient memory usage, and improved overall performance in data retrieval tasks. Next, we discuss the applications of optimal binary search trees. Optimal binary search trees are widely used in various applications including database indexing, compiler design, and network routing algorithms. Their ability to efficiently manage and retrieve data makes them a valuable tool in computer science and software engineering. Discuss what is a binary search tree. A binary search tree is a data structure that maintains stored data for efficient searching and insertion. Each node has at most two children, with the left child containing values less than the parent and the right child containing the values greater. This property enables quick lookups. Next, we discuss the dynamic programming approach. To construct an optimal binary search tree, we utilize a dynamic programming approach. This involves calculating cost of various tree configurations and selecting the one with the lowest expected cost. This method allows for systematic analysis and efficient tree construction. Then we discuss the challenges in implementation. While optimal binary search tree offers significant advantages, their implementation can be complex challenges, including determining the frequency of accesses patterns and efficiently updating the trees as data changes. Addressing their issues is crucial for maintaining optimal performance over time. Next, key definitions. A key is an element that can be stored in the binary search tree. The frequency of a key refers to how often it is accessed during operations. Depth is the distance from the root node to a given node in the tree. Next, we discuss the formulating the problem. To construct an optimal binary search tree, one must define the keys and their access frequencies. The problem can be formulated as finding the arrangement of keys that minimize the total search cost. This involves creating a cost matrix to keep track of the costs associated with different subtree configurations. Next, we are going to discuss the cost matrix. The cost matrix is a table that represents the cost of different combinations of keys. Each entry in the matrix corresponds to the cost of a subtree formed by a specific range of keys. Filling the matrix of a crucial for determining the optimal structure of the binary search tree. Next, example of cost calculation. Consider a simple example with keys A, B, C and frequencies 0.1, 0.3, 0.6. The cost for different configurations can be computed and compared. The optimal configuration would be the one that results the lowest total cost based on frequency of access. Next, we are going to discuss the building the optimal tree. After calculating the cost matrix, the optimal structure can be constructed. This involves backtracking through the matrix to reconstruct to the tree based on the minimum cost found. The root of the optimal tree is selected from the configuration that yields the lowest cost. Next, advantages of optimal binary search trees. Optimal binary search trees provide improved search times compared to unoptimized trees, particularly under skewed access patterns. They are especially beneficial in applications like databases where certain records are accessed more frequently. By minimizing search costs, they enhance overall system efficiency and performance. Next, we are going to discuss the limitations of optimal binary search trees. Constructing an optimal binary search tree can be computationally expensive, especially for large data sets. The dynamic programming approach, while effective, may require considerable memory resources. In some cases, the cost of maintaining an optimal binary tree may outweigh its benefits if the access frequency changes frequently. Next, applications of optimal binary search trees. Optimal binary search trees are used in compilers for symbol tables and expression evaluations. They are also applied in database indexing where certain records must be accessed quickly. In network routing algorithms, optimal binary search trees can help minimize latency in the data retrieval. Comparison with other data structures. Compared to AVL trees and red-black trees, optimal binary search trees provides better average case search times under specific conditions. However, they lack the self-balancing properties of AVL and red-black trees. The choice of data structure should depend on the specific use case and access patterns. Conclusion of optimal binary search tree. Optimal binary search trees are powerful tool for improving searching efficiency. They leverage access frequency to minimize average search costs through careful structuring. Understanding their constructions and applications can lead to significant performance improvements in various systems. Thanks for watching my YouTube channel.